Hello and welcome to another episode on Amiga Retro Adventures. Yes, adventures indeed. Today will be adventures. I bought an Apollo 1260 card on eBay. It functions, as you can see. And I want to do an upgrade. So I'm going to be upgrading it from 50 megahertz to 80, hopefully. And it has some issues with it that I want to address to basically restore the card to its full glory. So just to make sure to prove to you that everything works just fine, I shall go into the programs folder and run sysinfo. This way we'll also know the speed difference between what it is now and what it hopefully will be. Speed test time. So around 39 MIPS and let's say 28 MFLOPS. And let's see what more specific information will reveal if I can remember where I put it. Yes, 1 second. There it is. So as you can see, it's a 68060 at 50 megahertz, revision 1 mask. 68060 FPU, MMU. I'm kind of hoping, because that's exactly what I paid for, so I know this eBay seller did not lie to me, which is a good place to start when you want to trust people. Anyway, so that looks good. So what we're going to do is I'm going to show you the card in its current state and kind of cover what we're going to do. So if you're interested to see how this is going to transpire, stick around. I'll be back shortly. Hello, we have returned. As you can see, this is the Apollo 1260 card that I purchased off of eBay. This is the front of the card and the bottom of the card with the 68060 in all its glory, plus the power supply adapter, because remember the 68040, which this card can support, runs at 5 volts. The 68060 runs at 3.3, so it needs a power converter, which looks like, as I remove this, like so. I love it when cameras don't want to focus. But there you go. So you basically have the IC there is the 3.3 voltage regulator. You got a bunch of capacitors and diodes and fun stuff. And that's pretty much all that does. So that takes the 5 volts that the card, or I should say the Amiga supplies, and bumps it down to 3.3 for the 68060 conversion. The card back here in view. One thing there's two things I want to do, several things, sorry about that. One is I want to upgrade the CPU to a newer revision, which is revision 6. It can run at higher clock speeds and cooler, so it's ideal for overclocking. I will change the 50 megahertz crystal right here to an 80. But there's another issue with this card that has me concerned, and I'm sure some of the observant ones of you would have noticed already. Let me zoom in slowly. Oh, there, almost there. Okay. As you can see, that is probably one of the chips that has been attacked by the nickel-cadmium button cell right here that supplies the power for the real-time clock. Now the clock does work. I tested it, everything works. It even still manages to hold a charge when I power it off and completely and turn it back on again. Everything seems to be fine, but I definitely want to replace that. Yeah, obviously. And a lot of people just remove it. And that's it. I always like the functionality of a real-time clock, even though I seldom ever use the feature. It's one of those things that's nice to know that you have that option. So I'm going to replace that with a rechargeable battery, but it's a lithium ion. And about 3 volts. They don't leak, and it will actually fit quite nicely there, and it'll sort of retain the functionality of the real-time clock. But you can see how bad this corrosion has gotten. It's even gotten into, let's see if I can get this to zoom in a bit more, the jumpers as well. See how nice and green that is. And anyone that has nickel-cadmium batteries lying on their motherboards or other Amiga hardware, remove them as soon as possible, because this should be able to be cleaned up relatively easily, but it can get much worse than just being unsightly and green. It can destroy the traces on the board, which of course will pretty much render the card or the computer inoperable. And if you can fix it, it is a very unpleasant experience, trust me. Trying to rerun traces is not a good idea. So I will prepare the removal of the battery and get all my tools required for this task, and with a bit of luck I won't end up destroying this. Oh, one more thing too. Sorry. Yep, zoom in there. This capacitor right here, apparently they go bad after a while, causes stability issues. It's probably the filter cap for the power for the processor. So I bought some replacements, so I will replace that capacitor as well. So I will be back shortly, and I'll have my workbench set up, and we will continue the task at hand. And I will see you shortly. Okay, welcome back. First thing, I guess we'll try to replace this battery and see what happens, I guess. Here we go. Take off the plastic part first. Maybe. Or maybe not even worry about that. Let me see what's underneath here. Yeah, let me just unsolder that. It'll probably be a lot easier if it's in frame. Okay, here we go. Let us unsolder the battery, shall we? If I can get my solder unspooled. Okay, here we go. 3 connections. Let me move this up a bit more in frame. There we go. I don't think my soldering iron is hot enough. Let's put it up to 410 degrees Celsius. There we go. 1. 2. This is not going well. There we go. 3. I do have a solder unsucker, but I did not want to bring it out due to the work. I resort to this cheaper mechanism, which doesn't work as well. Like, very well at all. And not good. Not good. Maybe I shall resort to that solder sucking device because it's much better than this. I will be right back. Okay, back again. I will use the desoldering station, hopefully with better luck this time. I will, in the meantime, touch these up here again. And hopefully I have better luck this time without destroying anything. Okay. Waiting for the station to get up to temperature. Ah yes, the sounds of suckiness. Okay, I think it's up to temperature. We shall find out. Nope, it is not. Trying to get this on camera view, it's kind of hard with my hand in the way, sorry. There's 1. 2. Yeah, that one's a bit harder, I see. Didn't want to come off so easily. always one. Be right back. Okay, with some cursing and swearing, but no destruction, I managed to remove the battery, which is right here. The slightly corroded remains. Oops, on the floor. This one was difficult to unsolder. I couldn't clear the hole. I managed to pull the wire out of it, but it's probably because there's a lot of corrosion here. So I'm going to have to clean up this corrosion. Basically, I'm just going to use some vinegar and some rubbing alcohol afterwards. And once I get that cleaned up, we shall return, and you should see how much better this will look before I do anything else. Okay, after a bit of scrubbing and soaking with the vinegar, it still has some on there. Now I'm going to let it finish, and I used this to pick away at some of the corrosion. It's actually not too bad. I'm going to let that soak a bit. But while I'm doing that, or sorry, should I say while I'm waiting for that to soak a bit more, we will remove this capacitor without destroying the board. And that's the key thing, without destroying the board. So I will attempt this. So first thing I'll do is remove the memory module, because I don't want it to get destroyed. I don't sound very confident doing this. I actually have before, trust me. But what I'm going to do is I'm going to put some Kapton tape around this cap so I don't overheat the other components by too much, and I will be right back. I seem to be doing a lot of cuts, but it's not very exciting watching me put tape on this, trust me. Very boring. Okay, we're back, and as you can hear, I have the hot air gun on. I need to regulate the temperature a bit. It's up a bit too high. Let me put her down. Oop, wrong setting. There we go. Okay, so as you see, I have the Kapton tape relatively protecting the other devices. I just don't want them unsoldering and then moving. So I'll keep them in place at least. If you really want it shielded well, use tin foil or something like that, but this should work for what we're doing. Okay, let's remove this, shall we? Carefully, cautiously. Yes. Without burning my fingers. Oop, fail. 1 second. Oh, I don't know what's happening here, besides the desired effect. This always looks easier on TV. Let me try this again. Well, I think I'm going to do more damage than good this way. Let me shut that off. Oop. Yeah, it looks like I'm making a nice mess of things. Let me just remove it this way. I've seen people literally destroy this with pliers, or this, for instance. Oh, that doesn't look good, does it? As long as I don't break the connections on the bottom. Oops, sorry, camera. Okay. Is this going to come off? Good question. The answer is no. There we go. One part. Perhaps the tape is holding some of this on. Must persevere. Oh, there we go. Well, better than nothing. Let me get my soldering iron, remove these pieces. I didn't want to leave the hot air gun on there too long. It wasn't coming off quick enough. I don't want damage happening here. It's sticking to everything. There's one, and the other one. Okay. Doesn't look too bad. Touch these up. Okay, not too good at the moment. I'm not happy with that. This is a mess. I don't have any room on this workbench, by the way. Actually, it's not a workbench, it's my very small kitchen table. I don't like the way that's flowing, so I shall add some flux. Because it is very dirty, very unclean, and solder needs to be very clean. So, there's one, two, that's better. Now, can I attach this capacitor like that? Of course, I can't leave it like that. I have to use my very unsturdy hands and attempt to put this in place. Not so amazing. Not going very well, is this? It's kind of lopsided? Yeah, by quite a bit. Not sure that's the right size for this or not. Bear with me. No, take this tape off. It's not helping me any. Okay. Bit of out of range here. Okay, so I think the problem is I have to get both at the same time. It's not working very well. This is not going well at all, my friends. Ah, damn it. There's everything in the way right now. Everything. I'm off camera. There we go. Let's try this again. This is just a debacle. That's too much solder is part of the problem happening here. Where's that solder sucker? I had the mechanical one. There you are. There's one. Two. You can actually see that it's marked positive, so I should know how to put that back on. I observed the polarity previously, but as I have more capacitors, I'm going to try another one. One moment. Okay. Just to be certain. Just to be certain. Okay, there we go. Let me clean that up a bit. right here, still in frame. A bit of isopropyl alcohol. Get it nice and clean. I think this time I'll put down the whole unit as one piece. Maybe I'll use some of my Kapton tape or something. Wouldn't be a bad idea. Needs to be a bit thinner. I'm going to cut a piece of that tape that I have lying about here. What a mess this is turning into, but it is for a worthy cause. Yes? Okay, just bear with me one moment. I am lining up this capacitor with some tape. And we will see if I can not get this to work properly. Now I know why they make robots. Damn it! Okay, that's working out really well. See, in theory, this was a good idea. It worked. Well, close. At least it's flat now. Let me clean my tip, sizzle, and then find the solder and attempt to position the end of this. Damn, I wish that tape would stick. Let me try this again. I'm not happy with any of this. Pardon the cursing, but it comes with these jobs. These are put on by very quick machines. Oh, there's going to be a lot of editing in this video. Ah, damn it, what am I doing here? This is turning out to be much worse than expected. Okay, party time. Anytime now. I'm going to do this by hand here. Can I tack that on there? If I had some solder, maybe? Okay. Don't try this at home. Or do, I don't care. This is not cooperating. Okay, that looks not too bad, actually. So as long as the other end doesn't unsolder itself, I should have success. Here we go. In frame. Oh, 1 second. This workspace is horrible. I apologize. Okay. Not too bad. Oh, my glasses. My glasses. I have to use many glasses to do this. Okay, that end looks okay. And I'll tack the other end on. Right here, without making a mess. Okay. So, at this stage, I'm going to use a bit of flux to clean up that connection, and I think that's not too bad. I did observe the polarity. Clean the tip off one more time. Still in frame. I have to, the camera's not in front of my face, it's off on an angle, so I have to make sure that you're actually seeing something of use. Okay, this side first. That's one. And that's two. Not bad, I'd say. Okay, the capacitor is replaced. That only took 500 years, but I have nothing better to do. I keep hitting the camera. Sorry. It is literally right beside me. I have like a very small workspace. So that looks pretty good. So what we're going to do now is I have to try to free up this hole here so I can mount, one moment, over here, this battery. Yay. And it's only got 2 prongs, but I can make it fit. You can kind of go kitty corner, like from here to there. That's negative, which I believe is the bottom of this. So the negative is the small piece here. The positive is on the top. So I might have to trim this off a bit, but that's no big deal. So I will prep the hole, this stubborn hole, and I shall return. And I'm back about an hour later. As you can see, I cleaned up this area. I reflowed the, whatever this IC is right there, cleaned up the connections a bit. And notice I don't have the battery on here, but I do. There was no room due to the size of it, and I can't have it protruding on the edge here because that's where the trapdoor is. But I did manage to install it on the bottom. And as you can see, there's a gap in there. I could put a piece of rubber in there. I used to have little rubber feet that would fit in there to prevent any possible contact. But unless you sit on the stupid thing, it's not going to go anywhere. And as you can see, it's clear as the edge, so it should fit in the trapdoor, no problem. The only thing I had to do is I had to scrape. You can see that solder blob right there. I had to scrape some of the mask off the ground to get the 1 lead to solder to it. But as you can see, it's pretty strong. It's not going to go anywhere. And to prove that it works, I shall put this back down and take a look at the meter with a bit of glare on it from my lovely lights here. So this is negative, and this is positive. Right. There we go. That's not doing anything. Oh, there we go. About 2.989 volts, about almost 3 volts. So there's power. And since it's in the correct polarity, it will charge when the system is on. So next step I'm going to do is remove this chip right here, the 68060 revision 1, which you only know by using certain software, with this one, which is supposed to be a revision 6. So apparently, well, I've done it in the past, as long as this is a true revision 6 of the 68060, I can clock it at 80 megahertz by putting in the 80 megahertz chip, well, crystal, that I purchased, which is right there. And I have no idea if that's focusing or not, but trust me, it's 80 megahertz. That will go in here, and then that will be it, I hope. So I'll be back once I attempt to pry the old chip out and put in the new, and then we'll fire everything up. I'll see you in a bit. Okay, welcome back. I have returned. I have removed the older 68060, the revision 1, and replaced it with the revision 6 mask, which should allow overclocking. I'm going to clean the surface of this, obviously, and I'm going to attach the heatsink. You can still use this in a wedge Amiga 1200, but you probably would have to leave the trapdoor off or cut a hole for it. Actually, no, you don't need to do it. This one actually faces up. This may not in said case. This is ideally for a tower, actually. I'm just rambling here. Yeah, the CPU on this actually faces the keyboard internally. Okay, looks cleaner, I guess. Clean this up a bit more. Polish. And going to put the heatsink on. One of those self-adhesive type. If you have a tower, you can probably throw a fan on this. So I'm going to attempt to put this on evenly without being too askew, which I'm pretty good at. I do askew very well, thank you very much. Try to center this the best I can. Take a look at that 1 second. Down a bit more this way, or maybe up. Oh, still. The shadows are playing tricks on me. I can't tell necessarily. One moment. Fine-tuning the process. I'm a bit OCD, so I must have this perfect, damn it. Not bad. I say it's a go. So I'm going to put some pressure on this. Count to 30 very fast. Make sure it adheres. I don't want to put too much pressure on this. I'll break it. And that would undermine everything you just watched me do here. Not quite 30 seconds, but that should do. As you can see, not too bad. I centered it relatively okay. So now I'm going to put the crystal, that is 80 megahertz, in place. I'm getting that right now. And I will install this. You can see there's a square notch there. It's a slightly metallic square piece at the end here. The edges are roughly rounded. The positive, I believe, is the one that's actually square versus rounded. Make sure I actually have this lined up properly. It's a bit on the high side, so what I will do is cut that down a bit. I will be right back again. Okay, as you can see, I have installed the crystal. It's relatively level. It doesn't wobble, which is good. So I had to cut the legs to the proper length, and that should be it. So I'm going to install the RAM, put the jumpers back on. Speaking of jumpers, let me show you something as I trip over the tripod. Okay, move the memory out of here. These are the jumpers. I've actually been soaking them in. Can this focus? Whoa. Been soaking them in vinegar for the last 2 hours. I've been working on this. It's pretty much removed, I'd say 90% of the green, horrible corrosion that was on there. This is actually the second bath. The first one, I've already changed it out. It was really, really green and disgusting. So when I come back for the final time, we will install this card and see if it actually works, or if I just pretty much destroyed my entire eBay purchase. So I will be back once again. So as predicted, I could not put the Accelerator card in the case with the keyboard attached because of course the heatsink is too tall. I guess as a guide, maybe a bit shorter, but they're kind of hard to find. Worst case scenario, it can be removed, but I'm so used to using a tower, I keep forgetting about the limitations. But anyway, regardless of that, let's turn this on and see what does not happen. So let me just move this down a bit. Oh, wrong direction. 1 second. Oh, maybe I'll edit this out to so you don't have to get. Yes, I'm going to zoom in a bit. Okay, let's turn it on. Oh, signs of life. Of course, I need to have the monitor on the right input. It will reboot because it's got to put stuff into memory. Okay. Well, it's pretty good. We have our memory. That's fine. It looks like I did not blow anything up. Okay, let's do our quick system test. Sysinfo. And speed. Remember, last time we had around 39 MIPS. See what we get now. Look at that, 62 and 44. We went from 39 and 30, I think. I can't remember exactly. You can go back in the video to see, but that's a substantial speed increase. And I shall quit that, and we will run the tool just to make sure I have the correct revision that I was promised, like the mask. It should be revision 6. And here we go. And we do. Look at that, 68060, 80 megahertz. That rocks. Revision 6, full-blown CPU. And of course, it's not on load right now, but these things stay pretty cool. That's why they have to be the revision 6. It was the last revision of the 68060 that Motorola made, so they're slightly smaller die. They can handle a bit more, like thickness, die thickness. They can handle a bit more heat. That's why they can overclock. You will not be able to overclock the processor that was in here, the revision 0, or the one that was in here, the revision 1, to 80 megahertz. It just won't handle it, but not bad at all. So I would say that this is a success. And as you can see, I'll just zoom down here a bit, zoom in. Yeah, that battery is perfectly situated, and it just comes close to the plastic piece here, but doesn't quite touch, so perfect. Oh, what was that? Something happened. The infamous guru meditation. I think I touched something I wasn't supposed to. There we go again. Reboot. So I'm going to do one more test to make sure the clock works. So I'm going to check the clock. Where are we here? Time. I notice there's some graphics anomalies. I'm not sure if that's to do with the overclocking or not. It's a mixed bag, but it should be okay. But let me get to the time. No, it's not working well. Oop, it has locked up. Okay, so now I'm going to make sure the real-time clock works. So let me set the date, because obviously it forgot because I removed the battery that was in it. And it's May the 12th at 5:20. Oops, 5. Oh, yeah, something is not right here. 17. I'll have to check some connections, including the edge connector. Put it at 5:21 too, that's fine. Save. Double check. Okay. So now I will shut it off and wait a few seconds and see what happens. Shouldn't take too long to power down completely. Okay, turn it back on. The glitches or the random crashes might be how I precariously have this thing situated. It also could be something to do with this board down here for the scan doubler. It often gives me grief. If it is the overclocked a bit too much, I can back it down to about 75 megahertz, give that a shot. And even 66. 66 is pretty reliable on most and still a good improvement from 50. But the main thing, this car has been pretty much restored to its former glory. Let's check the time again. And it has remembered it. Excellent. So the battery works, everything seems to function. Like I said, the random crashes or graphics glitches could be many things. Even the edge connector here could be dirty, other stuff like that. Or there's, like I mentioned before, if I take this off, often there's this card here, the Indivision. Geez, I can hardly focus on that. There we go. In frame. Perfect. Yeah, that it's the Indivision AGA Mark 1. It clips to the Alice. Where's the Lisa? I can't remember anymore. the graphics chip anyways. It clips to that, and it sometimes gives you intermittent crashes, color anomalies, a bunch of other stuff too. So, and that is pretty much it. Thank you for watching, and I'm glad nothing blew up and I got this to work and restored to its former glory. Until next time, take care. Hello, I thought I'd cap off this video just kind of explaining the instability issue. I tracked down the problem to two things, the instability being the random crashes and other anomalies that was occurring. One was the power supply I was using was a bit fickle depending on what Amiga model I used, so I swapped it out with another one that improved it somewhat. But the main reason was the revision of the motherboard. If you look on many forums, Amiga forums, you'll see that certain motherboards, especially revision 2B and 1D4, I believe, need timing fixes, and especially for the Apollo cards, that seems to be an issue. So I managed to dig up a motherboard that was a revision 1D1, and it seems to work just fine. To keep the heat down, I did remove the heatsink because I wanted to put it in this computer right here, my 1200, and with everything assembled without the keyboard hanging off and all that stuff. Let's see if I can get this back in frame. But yeah, so I removed that, and because of that, what I did is I also turned back the clock frequency, so I put another crystal in 66 megahertz, and I will show you. And there it is. And it seems to run just fine. It runs cool enough, doesn't cause any issues whatsoever. So the stability is pretty much top-notch now. So it does run reliably at 80. I tried it, but like I said, unless you have a tower case and a pretty good power supply, I would not recommend it. But 66 gives you a nice speed increase, and I will show you the results in sysinfo. The quick speed test. And there we go, 51 and 36. I think the stock before was at 50. It was 39 and I think around 30, roughly. So pretty good speed boost, all things considering. It makes it one of the faster Amiga 1200s you'll probably ever have. So that is it. Thank you for watching. Like I said, I just wanted to give you an update on that, and hopefully I'll have some more videos, at least one more, before the end of the week. So until then, take care. Hello, this should be the last part of this video. I forgot to mention what I believe was causing the main problem with this card being unstable, random crashes and whatnot. It is the card right here. This is the voltage converter. It takes 5 volts, drops it down to 3.3 that the CPU needs. And I will zoom in here for a second. You can probably already see I had to repair this card. Yes. So what it was is there's a trace that this wire has replaced, and it was burnt off, actually. I believe I received the card in that fashion, though it did work, but that trace is kind of important. I believe it's the sensing voltage that it needs to regulate, because without the trace being there, between these two terminals here, there's a negative rail and a positive rail, the CPU was getting 2.4 volts, which is almost a full volt less than the 3.3 that it needs. Frankly, I'm surprised the CPU even operated at such a low voltage, but that would explain why it crashed and other anomalies occurred. So as you can see, I replaced the trace nicely with that matching green wire, so it doesn't look too out of place. But that's what that was. If you watch the beginning of the video, you will see this card, or the adapter here, and you will notice that there's a weird looking area right along this edge where the wire is. And if you pause the video, you'll see that that trace is gone. So and it's easy to do because there's many pins on this, and if you offset it like here or on this edge, you can definitely fry some of the components, or luckily in my case it was just the trace. So there we go, and that was the main reason why this thing was horribly unstable. And that's all that I have to say. I just wanted to update you on that, and that's it for this video. Thank you very much. I know it was a bit long, but it's definitely worthwhile getting this card completely restored to full working condition. Well, that's it. Thank you very much, and thanks for watching.